Our next lesson is going to be over synthetic division. Synthetic division is a way to divide polynomials. So let's do an example. Hold on. Let's do 5x to the third minus 6x squared minus 28x minus 2 all divided by x plus 2. The first thing we need to do when we do synthetic division is make sure the polynomial we're dividing is in standard form, which means we have our highest order term first and then it decreases down in descending order. Now we need to check and see if there's any missing terms. See how I have x to the third, x squared, x, and then the constant. Okay, if there's any missing terms, we need to account for those whenever we do synthetic division, but we don't have any missing terms, so this one's okay. So, the first step for synthetic division is we take the polynomial that we are dividing with, the x plus 2, and set it equal to 0, and we get negative 2. Now, we always do synthetic division with a value of x, and so in this case, that's where we get that value of x. We put it in what we call the divisor box. Now, this is where it's important to notice if there's any missing terms. We need to account for those. All I want to write down when I do synthetic division is I want to space out the coefficients. So I have 5, negative 6, negative 28, and negative 2. If I have any missing terms, I need to put in a 0 for those coefficients. First step is to drop the first number down. Then we multiply by what is up in the divisor box. Okay, so when we do that, multiply times negative 2, we get negative 10. And then we add straight down. Negative 16. Multiply by negative 2, we get 32. Add straight down gives us 4. And then multiply by negative 2 gives us negative 8, and we get negative 10. Okay? Now, these numbers here are going to be the coefficients in my answer. So, I ran out of room, but this, whenever we divide it, the answer is going to be, if you look right here, I start with this line. Everything going this direction is going to be all my terms. This is going to be my remainder. Okay, so we'll worry about that here in a second. This is going to be my constant. This is going to be my x term. This is going to be my x squared term. That's going to be the coefficient of it. So you see that I have 5x squared minus 16x plus 4. Then I take my remainder, which is negative 10, and I add it back on over what we are dividing by. Negative 10 over x plus 2. That's the whole process of synthetic division. Let's do another example. Let's say I do 3x to the third minus 2x squared minus 150 all divided by x minus 4. Okay, so we do x minus 4 set equal to 0, gives us positive 4. I have an x term missing, so I need to put a 0 in for that. So I have 3, negative 2, 0, and negative 150. Bring the 3 down. 3 times 4 is 12. 12 plus negative 2 is 10. 10 times 4 is 40. 40 plus 0 is 40. And 40 times 4 is 160. And negative 150 plus 160 is 10. So I get 3x squared plus 10x plus 40 plus the remainder over what I was dividing by. Okay, let's do another example. Let's say I have negative, x to the fourth plus 3x squared minus 4x minus 5 divided by x plus 3. Just a different way of writing it instead of writing it in a fraction form. X plus 3 set equal to 0 gives us negative 3. I do have an x to the third term missing, so I'm going to put a 0 in for that. So the coefficient of x to the fourth is negative 1, 0, 3, negative 4, negative 5. So I get negative 1, 3, 3, negative 9, negative 6, 18, 14, negative 42, and negative 47. So the answer is, again, this is my constant, this is my x term, this is my x squared, this is my x to the third. So the answer is negative 1x to the third, or just negative x to the third, plus 3x squared minus 6x plus 14 plus the remainder, negative 47, over what we're dividing by, x plus 3. Okay, now, we're talking about polynomials in this chapter, so how can we use synthetic division? Well, we can use synthetic division to determine zeros. If the remainder of synthetic division is 0, then the x value we were dividing by is a 0 of the polynomial. Okay, so we defined what a 0 of a polynomial was in the last section. So, for example, let's say I have f of x is equal to x to the third minus 4x squared plus 9x minus 6. Is x equal to 3 a 0? Is x equal to 1 a 0? Two questions here. Okay, so what we're really looking for is we're looking for a remainder of 0. If we have a remainder of 0, then that x value is a 0. So let's try 3 out first. When we do synthetic division, this is not a remainder of 0. So that tells me x equal to 3 is not a 0 of f of x. Let's try 1. 1, 1, negative 3, negative 3, 6, 6, 0. So we got a remainder of 0. That tells me that x equal to 1 is a 0 of f of x. That's good. Okay? Because this whole chapter is about figuring out how to find the zeros. Now, how can we use that? Well, we learned last time that if we have x equal to r is a 0, then x minus r is a factor. So let's say I have f of x equal to 6x to the third plus 19x squared plus 2x minus 3. And let's say that x equal to negative 3 is a 0. Okay, that's known. If I do synthetic division, that will simplify it for me just a little bit. So let's see that. So we get 6, negative 18, 1, negative 3, negative 1, 3, and 0. So when I did that, if x equal to negative 3 is a 0, then x plus 3 is a factor. When I factor that out, I was left with this guy, which is 6x squared plus 1x, plus 1x minus 1. That's a factored form of f of x, which takes it to a simpler form. And we always want to try to factor down to a simpler form. Now, that's what we're going to do in the next sections with synthetic division. That's what we got to use synthetic division for. But let me show you one more thing. Let's say we have f of x equal to x to the fourth minus 2x to the third plus 4x squared plus 2x minus 5. And let's say that I tell you x equal to 1 plus 2y is a 0. Okay, that's a complex number. So all I want to show you is that you can do synthetic division with complex numbers. It's not easy, but you can do it. It's not pretty, let me say that. So let's do this. Now, I told you it was a 0, so we should be expecting a 0 in the remainder. So let's see how this goes. Get 1 plus 2i. Remember, when we add complex numbers, we add just the real parts. So we only have to add the negative 1 or the negative 2 with the positive 1. So you get negative 1 plus 2i. Now, the thing that goes in that position is going to be 1 plus 2i times negative 1 plus 2i. Now, I don't have the room to do that in the little over there in that area, so, and I can't do it in my head, so I'm going to do it over here to the left, just make it a little bit easier. To the right, excuse me. I get negative 1 plus 2i minus 2i plus 4i squared. The plus 2i and the minus 2i go away. So I have negative 1 plus 4, and I squared is just negative 1. So we have negative 1 minus 4, or negative 5. Okay, let me draw a little line just so we do not confuse the two. Usually you don't do that. I'm just doing that so we don't get them all mixed up with each other. That gives me negative 1. Negative 1 times 1 plus 2i is negative 1 minus 2i. Again, add just the real parts. Gives me 1 minus 2i. Again, I need some extra room because I need to do 1 plus 2i times 1 minus 2i. Now, I know I need to have positive 5. Let's just double check and make sure that's what we get. So we get 1 minus 2i plus 2i minus 4i squared. Again, the negative 2i and plus 2i go away. So we have 1 minus 4 times I squared is negative 1. So I have 1 plus 4, and I get 5. And that's what I was supposed to get, because the remainder is 0. Okay, that's just to show you that we can do synthetic division with complex numbers. We don't always have to, because there's ways of avoiding that, but that just shows that we can do it. It's a little messy, but it's not too bad. So that's where we're going to stop for today.